about some quarterly labs.
Yep.
We talked about the Pigpen, Snoopy, Tigger, Linus kind of assessment tool. Are there other functional things that you would throw out there or gold standards, or where would you kind of rank things if somebody was actually very serious about this? If we can rank it in cost or what you would get kind of bang for the buck or what you can squeak away with without emptying the bank account, what do you think are your top one, two, three, four, five things that you would
Sure.
do?
Yeah, so we can, I guess, try to rank them higher cost, more invasive to lower cost, less invasive. That tends to be a good way to go, and just start with like the most, I guess, precise, the most accurate, also the most expensive or the least accessible things. Gold standard would be like a mitochondrial function measurement that you would actually do a muscle biopsy or you do some work to isolate mitochondria. And then you got to keep those bad boys alive. And you're going to actually do some tests with them where you are going to basically provide the mitochondria different fuels and see how they respond, see how much ATP they generate. This would all be done in a lab. This is all quite laborious in terms of like just isolating the mitochondria out of the muscle after you get a muscle sample.
Ouch.
Incision and yeah, making an incision and like doing a little minor surgical procedure to extract some muscle tissue. So that would be the gold standard. You're going to find that in the research. That's great. I don't know how many people are doing that at home all the time. I think that would be a little bit less invasive, but the cost is way up there. Is doing nuclear magnetic resonance using an MRI or spectroscopy. You can use specific scans in the MRI to look at the metabolism that's occurring in your body in different areas, for example, while you're alive, and there's no cutting or surgical procedures to extract muscle. So again, non-invasive, very costly. That's becoming more common in the literature just because it's really hard to use biopsies to get some of these data points that we'd like. For example, even the labs, which we'll talk about, I'm sure, they're just a moment in time. And unless you repeat the labs associated with different things during exercise or post-exercise, like we have some of that data, but it's hard to do. Biopsies are equally hard to do because if you want to see a baseline mitochondrial function and then do some exercise and see what the mitochondria are doing during that time, you have to have someone get more than one muscle biopsy, and so it's just difficult to do. The MR helps a little bit with that. You can do the magnetic resonance, but again, cost. So alternate mitochondrial function test that would be even more accessible down the line here. There's Swab, which is a company that does cheek cell swabs, and then you can actually send those in and they will analyze. They will give you some data on what the various electron transport chain complex 1 through 4 are doing in your mitochondria. And so that's a great option. It's actually been validated in the literature to be roughly 80% plus 84%, if I remember correctly, in terms of like be lining up with what a muscle biopsy would produce in terms of those results. You get 84% without actually cutting your leg open. So MeScreen is another one. They use seahorse technology, which is super cool. Seahorse technology is like the cutting edge, and they do some really cool work to get a little bit more comprehensive view of mitochondrial function. Very new, so that would need some data, but it is possible you could actually purchase a MeScreen if you're super interested in that. Finally, we go to lab markers. So we've made it something that's more common, more that we see more regularly. And when you're looking at lab work, you want to look at specific markers that are kind of selective for mitochondrial function. The ones that are the easiest or most available would be lactate pyruvate and lactate pyruvate ratio. So that's 2 markers, and then you do some division and you get that third one as an extra bonus. So lactate is a byproduct, or lactic acid is a byproduct of anaerobic metabolism. So if you have higher levels of plasma lactate, that means that you're relying more on anaerobic metabolism at your baseline or while you're fasting, etc. Ideally, with these, you want the values to be under 2, so 0.5 millimoles per liter to roughly 2 millimoles per liter or less. If you see at rest your lactate numbers are quite a bit higher than 2, generally that's an indication your mitochondria might be having an issue. Sometimes there's other stuff going on. If you eat like a really, really high carb meal and some other things, you might be able to perturb your lactate slightly. But if it's a fasted thing, then definitely might indicate some mitochondrial issues. With that, the pyruvate is a marker of aerobic metabolism. Normally during fasting, pyruvate range is 0.03 to 0.1 millimoles per liter. During aerobic metabolism, like Brandon had mentioned, you get more ATP per unit glucose. You get more ATP and you have the ability to burn fat completely and use mitochondria. So a nice way to assess whether or not you're getting adequate blood supply, whether you're doing more fat metabolism, which you should hopefully in a fasting state. Hopefully your fat metabolism is upregulated a bit. And then you can look at the pyruvate or the lactate pyruvate ratio, which is a breakdown of your fuel use metabolism. What you want to see basically is a 10-to-1 ratio or 20-to-1 ratio, somewhere in that range. If you're on the lower side of that, that means you're burning a little bit more fat potentially and creating energy from there. If you notice that your lactate pyruvate ratio is considerably over 20, that would be an indication that there might be some opportunity to improve your mitochondrial function. There's not a ton of human data in this area in terms of how you might optimize some of this. I did find some with relation to COVID-19, people that were in the ICU when they had elevated lactate levels or high lactate pyruvate ratios. That was associated with poor clinical option or outcomes. It seemed like people that were more metabolically healthy did fare a bit better when it came to any illness, really, but that one in particular does give an idea of the blood flow, the oxygenation. So if you have a high lactate pyruvate ratio, that would indicate that you might not be getting blood flow or you might not getting the oxygen. So like, again, with respiratory illnesses or viruses like that, where you have issues with oxygenation, that would be important to keep in mind. There's a couple more, and then we're going to take a break. I want to hear from Brandon a little bit, but we can chat about maybe some exercise assessments. There's some newer values now that you could consider. They're more nice to haves because they're not quite there in terms of being widely accessible. And, our research data is not as voluminous around these, but it's GDF-15 and FGF-21. They show a lot of promise, but they're not perfect. They're kind of, again, nice to haves. I think lactate pyruvate and lactate pyruvate ratio are going to be the standbys for mitochondrial function. And there's obviously some other ones with a complete lab panel. You're just painting this picture basically of like what's going on in the body and trying to get a metabolic assessment, mitochondrial assessment. You can kind of blend that all together and then hopefully, yourself, based on your research and expertise, or in conjunction with a really awesome coach like my man Brandon here, you would put together a plan to actually address lab biomarkers, some of your energy levels. If you're, got certain Charlie Brown things going on that you want to address, you could get to work and you'd have a great partner with a great beard to do that.
That's all right.